is again day 11 in geometry, and we are coming to the end of unit 2, so we're trying to review things today. And it is Wednesday, October 22nd. October is almost over. It's happening so fast. Okay, so the first two problems I gave you on this do now are reviewing the exterior angle theorem. So, what we learned about in the exterior angle theorem, I'm going to make a little sticky note here, is that anytime I have a triangle where one of my sides is extended, there's a special rule we can use to solve for certain angles. If in my triangle I were to name the interior angles A, B, and C, my exterior angle would be this large angle that's created between C and D. So what this theorem tells us is, first of all, we know that the three angles in a triangle, what do they add up to? 180. 180. So I could write A, let me do the capital. Hang on. A plus B plus C equals 180. I also know that angle C and angle D add up to a certain number of degrees. 180. 180. Why do C and D add up to 180?
They make what?
They make a straight line. So they add up to 180. So I can write now, I'm going to put D right here. D plus C equals 180. So what we notice between these two equations is that when I add A and B plus C, I get 180. When I also add D with C, I get 180. So we should logically be able to say that since when I add C to both of these, that A plus B must be the same thing as D. So I could now write A plus B equals D. Because if I add D to C, I get 180. If I add A plus B to C, I get 180. So these must be the same value. If C doesn't change, these don't either. So this is what we're going to use as our exterior angle theorem. A plus B equals D, where D is the exterior angle. So in number 1, what could I use as A, B, and D? Go ahead, Jess.
I use the 70 as A and the 68 as B. And then
Perfect.
I just use X as B.
Perfect. So if I were to follow this picture, I could say 70 is like my A, 68 is like my B. I don't really need C here because we're going to skip over it and use X, the exterior angle, as D. So if I know that A plus B equals D, what equation can I write to solve for X?
70 plus 68 equals X.
Perfect. We'll just replace the values. A is 70 plus B is 68 equals, well, D is X.
Then your X equals 138 degrees.
Nice. 70 plus 68 should be 138. Yes, so 138, cross those off, bring down equals X. And that is our answer. Very nice. Okay. Do we have any questions about how I did any of that? Or does that make sense? Okay. So we're going to use the same concept for number 2, except now our triangle just looks a little bit different. In this picture, what could I label as A, B, and D? Yes, go ahead.
I use 29 as my A, and then 28 as my B, and of course X as D.
Perfect. So this is the same type of problem. My 2 angles inside of my triangle that don't touch my exterior angle, A plus B is D. So what equation could I write here?
29 plus 28 equals X.
29 plus 28 equals X.
X equals 57 for this.
Good. So we just add those together. 29 plus 28 is 57. And that is our X value. Good. Okay, so that's all that we have to do with the exterior angle theorem. We just know that the 2 interior angles that are not touching this exterior angle are the same as the exterior angle when we add them together. Okay. Any other questions about that? Do we feel okay about that? Okay. Okay. All right. Let's now look at the mid-segment theorem. So I'll make another little sticky note for this. I will just draw a triangle with a line through the middle. This line is the mid-segment because, well, you'll only know if I give you the markings. So if I know this line segment here is equal to this line segment, that means this has split that side in half. And this line segment will use 2 marks and 2 marks. These 2 are equal. So this center line is the mid segment. Let me pull up my little note cheat sheet for this. I just took a picture of it. Find that. Okay. So if this mid segment is X, how is it related to the longer segment opposite of it? You may have to flip back to your notes for day 9. There was a picture that we drew.
Like for what the mid-segment is double length.
Yeah. It's double length.
Yeah,
So this would be 2x. What that means is within this little line segment here, this side length, if I use some color, this is my length for x, that means I can fit 2 of those x's right here. I think this picture helps us understand it just a little bit better. So if you don't have that in your notes, this would be a great thing to write down. A picture to help us with mid-segment. So now that I'm looking here at this problem, I need to decide what equation I could set up to solve for x. I can't just say that 4x plus 338 is equal to x. Yes, I know that 2 of these will fit inside of one of those because this is the mid-segment. Let me highlight that in that same blue color. This is my mid-segment. So there's 2 of these that go into my longer piece. So the smaller segment is the one that we need to take times 2 so that 2 of those equals one of these. So the equation I would write for this one is exactly like it looks right here. 2 times 4x plus 338. And this one's a little bit more confusing than the exterior angle theorem, so we can run through more practice if anybody would like that. So I'm going to write 2 times 4x plus 338. And that's equal to what goes on the other side?
X.
X plus 235. Good. So the mid-segment, the smaller one, we take that times 2 to make it equal. So once I've done this, I've set my equation up. What do I need to do next? Distribute. Good. I'm going to draw a line through my equal sign just to keep me organized. I might run out of room here. We'll see. And we're going to distribute 2 times 4x. What is 2 times 4x?
8.
Good. 8x. And 2 times 338.
676.
676. So I'm done with that. And we'll bring the rest down. Equals x plus 235. So now I have this equation. What should I do? Yeah, let's get our x's on the same side. So let's subtract x from both sides. We'll get rid of that one. Bring it over here. And 8x minus x. Good, 7x. And we just bring everything else down. So what comes down?
676.
Good, plus 676 equal, good, 235. Okay, I'm going to move that sticky note out of the way, and I'm going to add a sticky note under here to continue my problem. So what would I do next?
Subtract 676.
Yes, let's subtract 676.
Get negative 441.
Negative 441. All right. So that cancels. Negative 441. And what comes down?
Your 7x equals.
Good, just 7x. And my equals, and now I just have one last step.
Divide by 7.
Divide by 7. Okay. So the 7's cancel.
Negative 63.
All right, x equals negative 441 divided by 7 is, you are correct, negative 63. And that's our answer for number 3. Okay. Let's copy that and And now let's look at number 4. So I guided you through number 3. And remember, what we did in number 3 is the smaller length is what we multiplied by 2. and then we set the two values equal to each other. So for number 4, what should we do?
We'll do 6x plus 450.
6x plus 450, that's the mid-segment.
We'll times that by 2.
That is the value that we will multiply times 2. So we have both of these values. We'll set them equal to each other, but we'll multiply times 2 with the mid-segment. So let's do that. All right, 6x plus 50 equals, and I'm going to add that times 2 here in just a second. 4x plus 412. And we multiply the shorter one times 2. So there's our equation. And now that that is set up, what happens next?
You distribute your 2.
Good. Distribute your 2.
2 times 6 is 12x.
12x
2 times 450 is 900.
is 900. Good. So I have 12x plus 900.
And then you bring everything else down.
Bring everything else down equals 4x plus, bless you, 412.
And then we can backboard it to each side.
Good. So now let's get our x's together. Let's subtract 4x from each side. So minus 4x minus 4x. And what happens here?
Your full it becomes 8x.
Yes, 12x minus 4x is 8x.
Bring down your 900.
Good. 412. Bring down plus 900 equals, bring down 412.
You're going to subtract 900.
Good. We'll subtract 900.
You'll get a negative answer.
Negative answer? Yeah, you
It'll
will.
be negative 488.
Good. Negative 488. Bring down equals, bring down 8x.
You divide by 8.
Good. Divide by 8.
Your x equal to negative 61.
Awesome. Yes, that is correct. X will be equal to negative 61. Okay, so that was number 4. Okay, any questions or confusions about that one? Are we feeling good? Pause that for a minute while everybody writes and catches up. And then we'll do our Pythagorean theorem. So I'm going to scooch this back a little bit and move my sticky notes out of the way. Now, for number 5, we are using the Pythagorean theorem. We're solving for a missing side length. What is the Pythagorean theorem again?
A squared plus b squared equals c squared.
Good. A squared plus b squared equals c squared. And with A, B, and C, does it matter which number I put in for each spot?
It doesn't for A and B, but C needs to stay,
Yes.
variable.
Yes. So A and B, you can put either of the two shorter sides, right? But C is always represented by which side length? The longest side. Does anyone remember what that longest side is called? Hypotenuse. The hypotenuse is always the one right across from 90. That is always your C. Always. So we're going to write C next to it. So X and 10.6, those can be A or B. It won't make a difference. I'm going to use A as my X, or X will be A, and then 10.6 will be B. So now that I have A, B, C, let's plug them in. What equation could I write here?
X squared plus 10x squared equals plus 4 squared.
Good. X squared plus 10.6 squared equals 12.4 squared. Okay, so we just plugged in A, B, C. And then that. So, draw a little line. What should I do first?
Well, your x times itself is going to be 2x.
Well, X times X. If it was X plus X, that would be 2X. But this is X squared, X times X. I can't really do anything with that just yet. But there are two other items I can do things with.
Take 10.6 times itself.
Yes, 10.6 squared is 10.6 times 10.6. You're doing it times itself.
It'll be 112.36.
Yes, and remember, you can also use the squared button on your calculator. I'll do, see if it'll focus on my screen. .6 squared, enter 112.36. Good. 112.36. Bring down equals. Bring down x squared. And 12.4 squared, right? That will give us 153.76. So now we should have x squared plus 112.36 equals 153.76.
Don't you subtract 112?
Yes, because we want to get x by itself. And the only way to do that is to get rid of everything else first. So we'll subtract 112.36 from both sides, which gets rid of it over here. And over there, let's see.
$41.4.
That's the same number I got. 41.4. What comes down on the other side?
Your x squared.
X squared. Are we done?
No, you gotta find the square root of 41.4.
Yes, we don't have x yet. We do have x squared. So we need to find the square root of both sides. And that's your final step. That gives me x by itself equals, let's see, 41.4, the square root.
6.43.
Yes. 6.434283177. You don't have to write all those decimal places. I'm okay with 6.4. I'm okay with 6.43. I'm okay with 6.434, whatever you prefer. I'm going to write with 2 decimal places. I'll do 6.43. And that is our answer. Right. And any questions on that one? Okay, I'll leave that up again for just a minute or so. If you are finished with this, go ahead and get your notebook out. We are going to do a little bit of practice. Then we're going to take some notes on the last thing we'll talk about in Unit 2, which is special right triangles. So I'll leave that up while I title my page and get this ready. Okay, so putting that to the side, we are still in Unit 2. And here will be our notes for day 11. That's what today is, day 11. And I was thinking about this. I actually would like to give us the notes on special right triangles first, just so it's organized in your book. And then we'll do some more practice with our do now stuff, the mid segment and the exterior angle. And again, it is Wednesday, October 22nd. Okay. So we've been talking about triangles. We've talked about how to classify them. We've talked about how to solve for a missing side length in a right triangle. That's where we use the Pythagorean theorem that we just did a problem on. But now we're going to talk about special right triangles. And that's literally what they're called. They're just called special right triangles. So we have two special types of special right triangles. And for our notes, we're going to split this page sort of right in half. So I am going to fold this page a little bit and give myself a little crease as a guideline. And then I'm going to draw a straight line all the way down to the bottom of the page. Okay, well, that crease wasn't super helpful. I'm going to make it a little different than that. So we'll start right here. Bottom of page. And once you've split your paper, the first title, or the first type of special right triangle, we actually name it by the measures of its angles. This is a 30, 60, 90 triangle. And the second type is a 45, 45, 90 triangle. So once you've got those titles down, we're going to draw a couple of pictures. Now, this one is very important to have in your notes. This is a page that I would recommend putting a little tab. So I'm going to go ahead and do that, because you will need this later on. I'm going to cut this little sticky note and make a little tab for myself. All that special right triangles. sticks out when my notebook is closed. Okay. So our 30, 60, 90 triangle, we're going to start with drawing a line that goes straight up and down. And I'm going to make that line about 2.5 inches long or so. Do another line that is a little bit shorter than that. We'll go with roughly 1.5-ish.
How long was that first one?
That first line I drew was 2.5 inches. The second line I drew was a little over 1.5. And then my hypotenuse will be close to around 3 inches. So I didn't draw it perfectly, but close. It's important that you don't make your legs the same size. One of them needs to be shorter. And we will label this by its point. A will be that bottom point where the 90-degree angle is. B will be this top point. This will be the 30-degree angle. C will be this last point. That will give us our 60-degree angle. So inside of my triangle, I'll give myself that little box for my 90. I'll write 30 on my B angle, and I'll write 60 for angle C. Once you've done that, I'm going to start drawing our 45, 45, 90 triangle. Now for the 45, 45, 90, we need our two lines that create the 90-degree angle. They need to be the same length. So our legs are the same size. So I'm going to start with a straight line up and down as nice as I can. I'll make that about 2 inches. And then I'll make the other side length about 2 inches, the same size. And then my hypotenuse will be bigger than 2 inches. It will be about 2 3/4, maybe a little bigger than that. There. Have our 90-degree angle. And then our two 45-degree angles. So we don't mix our numbers up, we will label our corners, our points, instead of A, B, C, we'll start with D on the 90-degree, and then E on the 45, and F on the other 45. So A, B, C, D, E, F. And I'll let everybody get those drawn up to this point before I give you more. You're still working on drawing these, that's okay. I'm just going to give you a couple extra things. Now we have to label each of the side lengths, because the way that special triangles work is that there's kind of a proportion that's created. Every single time, these are the angle measures of your triangle, we can label AC, this bottom side length, as X, So from A to C, we have x. From B to C on the hypotenuse, we have 2x. And on the other leg, from A to B, we have x square root of 3. Now that becomes a mouthful. X times the square root of 3. Instead of square root, I'm going to try to remember to explain this before I start saying it. You can also say radical 3. That means square root. So it's x radical 3. X times radical 3 is what that is. So we have x, we have 2 times x, and we have x times radical 3. On our 45, 45, 90 triangle, my 2 legs are both x because they're the same size. And then my hypotenuse is x times radical 2. So make sure you have these pictures drawn accurately because this will be your guide to solving problems with special right triangles. All the labeling for them, so I'm going to pause my screen and I'll make sure everybody's got that done before we start working a problem out. All right, so first we're going to look at how we use a 30, 60, 90 triangle. For example, this is what you will see when we have these types of problems. You will be, first I'm going to write examples so we know this is the first one. You're going to have some information that is given to you. So it'll say given. And then you'll have information that you need to find. So find. And I will give you that AC equals 25. And you need to find AB and BC. So instead of one side length missing, we only have one side length. We have to find the other 2. The Pythagorean theorem will not help us with this. So here's how we do this. First thing I would do is I would look at my picture and decide what is AC other than 25. So I'm going to look at point A and point C. What is the label in between A and C? X. So right off the bat, I'm going to write equals X. So I know that AC is 25. So AC is X, so 25 is X. If I know that X is 25, I can use this to find my other values. So let's look and see what is AB labeled as. X radical 3. So I don't know the value yet, but I do know that AB is X radical 3. And what is BC?
2x.
2x. I don't know what BC is, but I know that it's 2 times x. So keeping in mind that x equals 25, let's use that to find the other lengths. So down below, I will write x equals 25. And let's start by solving for BC, just because that one looks a little bit easier. So if x is 25 and BC is 2x, how can I use the 25 and the x to help me find BC?
Plug it in.
Plug it in. X is 25. 2x. Let's do 2 times 25 because that's what x is. Plug it in. So 2 instead of x, 25. Plugging it in. So what is BC? 50. Not so bad. So we already have our BC. BC is 50. So I'll write that over here, 50. Now I want to find AB. So if AB equals x times radical 3, can I just do the same thing I did for BC? I can. I can just plug in 25 for x. I'll put 25 where the x is here. So we have 25 radical 3. And all you have to do to solve this on your calculator is type 25 second square root 3. That's all I type, 25 radical 3, just like this. I hit enter, 43.3. Good. So, AB equals 43.3. And that's it. You got your answer. So there is an example of your 30, 60, 90 triangle, finding your missing sides. So I'm going to give you an example for the 45, 45, 90 as well. We'll run through that. And then we may take some little notes as well to help us, give us kind of a guide to know what to do at each step. So going over to the 45, 45, 90, here is your example. You are given that DE equals 12. I need you to find DF and EF. DE is 12. What else could I label DE with?
X.
X. On my picture, from D to E, we have X as our label. So, if DE equals 12 and DE also equals X, what does X equal? 12. X equals 12. What is DF labeled as?
X.
Also X. What is EF labeled as?
X radical 2.
X radical 2. How can I use that to find my missing values?
Plug the 12 in for your x's.
Plug the 12 in for your X's. So I'll start with DF. DF equals X. And I know X equals 12. This one should be an easy one. What's DF?
12.
12. I just plug that in and, well, it's 12. Those will always be the same, the two legs for 45, 45, 90. So we know that DF equals 12. Now we'll look at EF. We said EF equals X radical 2. So what will I do here?
Take 12,
Mm-hmm.
like for the X.
Plug in 12 for the X again. So we have 12 radical 2. What do we get?
It'd be 16.97.
Perfect. 16.97. There we go. Nice. Okay, so we're following the same process for both types of triangles. We just have to remember that the triangles don't have the same x, 2x, x radical 2, or x radical 3. So keep this page handy so you can look back and see what those values are. Can I move this, or does anyone still need it? I can wait. Anyone still copying? Okay, I will wait just a minute. Okay, so I am going to flip my page and we're going to write out the steps that we just followed, just so we have another little thing to help us. So this is the day 11 notes continued. Special right triangles. So whenever we're doing this, the first thing we did for both problems is we labeled our AB, our AC, our BC, all of those side links, we labeled them with their X values. So we're going to write label side lengths with values. I'll put a little, for example, we said like AC equals X. X radical 3. These are just examples. See you, Jess. Step two. Step two, we didn't have to do a whole lot of because I gave you problems where you didn't have to really do this next step, but we're going to still write it, and I'll show you one where you'll have to do second step. Solve for X. If you don't already have it. I'm gonna write in parentheses, solve for x if it is not given. Not already given. Once you solved for x, the third step is just to plug in the x value to solve for the other side lengths. These are 3 steps we take whenever we use special right triangle. For the next 2 problems that I'm going to give us to practice with, I'm going to create a little miniature picture of those special right triangles so I don't have to keep flipping my page back and forth. So here is 30, 60, 90. $45, 40, 90. So, and I want to move these. And can I scoot this up? You still need.
Can I see that?
I can
have
stick
the
with
already-
Yeah.
Sorry.
You're okay. No, you're
I'm
good.
sorry.
No, don't be sorry. You're fine. Oh, wait a minute. I'll button pause it. Okay, so I'm gonna move these over just a little bit, and here is the next one we'll look at. This time, I will give you B equals 43, and you need to find A, C, and B, C. So we are talking about a 30, 60, 90 triangle. So I have my problem. What does step 1 say to do?
Label side lengths.
Label side lengths with your x values. So looking at my picture, from A to B, what value with x is labeled? X radical 3. From A to B is X radical 3. So we need to write AB equals X radical 3. What is AC labeled as?
Radical, no, time.
2x.
AC. Here's A. Here's C.
No, that's it.
X. Good. So that's X. And what about BC? 2x. Good. Okay, so step 1 is done. We labeled all of our side lengths. Step 2. Solve for x if it is not already given. Do I know what x is? I don't. I don't know what x is. So we need to solve for x this time. We are going to use the one number that we've been given, which is 43. And what's lovely is if I cover everything up, I already have an equation. 43 equals x times radical 3. So what I'm going to do is I'm going to write that down here. 43 equals x times radical 3. Just going to write that we're solving for x here. Solve for x. So 43 equals x times radical 3. Now, radical 3 throws people off because this radical 3, we're treating it like it's just a number. The reason we don't write the number out is because if I put radical 3 in my calculator, you'll see how complex of a number it is. Radical 3 is 1.7320500808, and then it continues on forever. That's what's called an irrational number. It goes on forever and ever and ever. It can't be turned into a fraction. It stays as a radical. So, keeping that in mind, all this means is x times the number that is radical 3. This is multiplication. So, how do I get x by itself if I'm trying to get rid of the multiplication here? Divide. Instead of messing with that square root, we are just going to divide by radical 3. Because that'll get rid of it. So we do that on both sides. Draw lines in my equal sign, keep me organized. Okay. So I divide both sides by radical 3, and if it helps you to write divided by radical 3, I know sometimes just writing the fraction, you look back at it later and forget that you're dividing. That can help. So I'm dividing both sides by radical 3. That canceled that, and I can bring down my x by itself. I can bring down my equal sign. And now I need to do 43 divided by radical 3. You type it in exactly the way you say it. 43 divided by, that's just your division symbol. Here, I'll move that. Second x squared to get your square root, your radical 3.
24.8.
Enter. You're going to get a funky number, but that's okay. 24.826066158, and so on. I would be fine with 24.8. I'd be fine with 24.826. I'd be fine with 24.83 if you round up. I'm going to put 24.8, keep it simple. So 43 divided by radical 3 is 24.8. And what did we just do?
Found x.
We found x. Step 2 is done. We solved for x. This is as hard as these problems will get. It won't get any more complicated than this. Hardest thing you have to do is divide by a radical. So I know that x is 24.8. That was step 2. What do I do now?
Plug that in.
Plug in your x. We can solve for the other missing sides. So if x is 24.8, let's look at AC. What's AC? 24.8. Good. Done. Done with that one. How about BC?
2 times. Yeah, multiple.
Yep, just multiply that times 2. If BC is 2x, write that. BC equals 2 times x, and x is 24.8, then BC equals 2 times 24.8. You're just going to plug that in. And we should get, let's see, I'm getting 49.6. You guys getting the same?
Yep.
Perfect. Perfect. So BC equals 49.6. Write that here. 49.6. Nice. And that's it. That is it. That is it. No, it's normally the time I would give you a break. Are we ready for a break? How are we feeling? Are we okay? What I will do. We're going to pause our video and let's take our break as normal. It's about 2:10. So we'll take 15, bathroom, drink, anything you need to do, you can run out, come back in. We will start back up, do some more practice with this and the mid-segment theorem at 2:25 in 15 minutes. 2:25. We're going to go ahead and come back from our break, and I want to give you just at least one more problem to practice with in your notes. I'm going to put that one just right beside this one we did here. So I'm going to draw a line just to separate. And this time, the value that I will give you, let's see. This time we're going to use a 45, 45, 90 triangle where we have D, E, and F. So, you don't know DE, you don't know DF, but I'm going to give you, your given is that EF equals 135.4, and you will find DE and D. So again, we're looking at a 45, 45, 90 triangle. So we're going to use the same 3 steps that I have written above this problem. Step 1 says to label the side lengths with your x values. For example, I said you could label your AC as x or AB as x radical 3. This time we're using D, E, and F. So looking at my picture, I'm going to start with the value I was given. I was given that from E to F, I know it's 135.4. What is the x value that EF is labeled as on my picture? X radical 2. There's E, there's F, so EF is x radical 2. So I'm going to write that here. X radical 2. Now, what is DE?
DE is X.
Good. From D to E
Is it?
is X. And what about DF?
X.
Also X. Good. So, I have done step 1. I labeled all of my side lengths with my X values. Step 2 is we need to solve for X if it is not already given. Has X been given to us? Do I know the value of X?
X equal.
Do I have a number here for X? I don't know what X is yet. So I need to solve for X. What can I do to solve for X?
Write it out.
We're going to write it out. I do have that 135.4 equals X times radical 2. So why don't we use this as an equation and solve for X? So I'm going to rewrite that below. 135.4 equals X radical 2. Now remember, this just means X times radical 2. So if I'm trying to solve for X, if I'm trying to get X by itself, what could I do here?
Divide it.
Divide it. What am I dividing by?
Radical 2.
Yes, I want to divide both sides by radical 2. So divide by radical 2 over there and divide by radical 2 over here. And what happens over here with my radical 2's and my X?
The radicals cross out.
Yeah, they cancel. Gives us X all by itself. Bring down my equal sign. Now I just need to type in 135.4 divided by radical 2. Here's the number I'm getting. You guys getting the same number as me?
Mm-hmm.
Awesome. So about 95.7. Okay, so are we done with step 2? Yes, we've solved for X. So now that I know what X is, we can move to step 3. Plug in X to solve for missing sides. So I know X is 95.7. How can I use that for DE and DF? Plug it in. So I replace X with 95.7, which means, well, both of these are X. And I know what X is, so both of these are 95.7. Good. 95.7. 95.7. And that's it. You are done. Okay. Any questions about that? Okay. So, the plan for the rest of today, now that we've done quite a few examples of each, is if you, or if any of you would like to stay to practice that mid-segment theorem from earlier and the exterior angle theorem, we'll do some practice with it tomorrow as well. But I do have some little worksheets here ready that we can absolutely go over. However, I also have your exit ticket ready today.
You go.
Oh, I know. I'm ahead of the game today. Oh, I am gonna pass that exit ticket out, and all the exit tickets, thank you, is this, the day 11 exit ticket. You have a 30, 60, 90 triangle. I don't give you the labels, so you need to look at your notes. I give you a 45, 45, 90 triangle. Same thing, I don't know the labels, so you'll need to do that yourself. And you will be solving for the missing sides just like we did in class. So that is your exit ticket. I'm going to just show it on the screen for anybody that's not here and is doing it at home. And there's number 2. Okay. And then I will pass this out. And that is all. So let me freeze my screen and I'll let y'all have that. The end.